Hello, today I'll be doing number 63, which is find the integral of x squared over x squared minus 1 to the power of 3 halves. So we should recognize from the last lesson that this looks like a place where trig subs might be useful, specifically secant. When you have the x squared minus a squared, you can sub x equals a secant theta. So if we substitute in secant squared theta over secant squared theta minus 1 to the power 3 halves, we also can't forget the dx, and the derivative of secant theta is secant theta times tangent theta. So we now have this. And now we just simplify. At the bottom, we can use the secant squared theta minus 1 is just going to be tan squared theta. Something squared raised to the power of 3 halves is that something cubed. So now you have secant squared theta over tan cubed theta multiplied by secant theta tan theta. So that reduces the power of tan by 1 and increases the power of secant by 1 because tangent's in the denominator. So now you have secant cubed theta over tan theta, tan squared theta, excuse me, d theta. And now we can simplify that just using the fact that tangent is sine over cosine and secant is 1 over cosine. We get cosecant squared secant theta. Integral of cosecant squared theta secant theta. And it would be a lot easier here if we used another identity, cotangent squared theta plus 1 equals cosecant squared theta, and you'll see why in a second. Cotangent squared theta plus 1, substitute that in. And we now get integral of cotangent squared. That's just going to be cotangent theta cosecant theta plus secant theta by the distributive property. And the cotangent theta, cosecant theta should look familiar. It's the antiderivative, or it's the derivative of negative cosecant theta. So you now have negative cosecant theta plus, this is just to memorize, ln secant theta plus tan theta. That's the antiderivative of secant. So now we have all the tools we need to substitute back into our original expression. Yeah, so it's just going to be this. ln of the absolute value of secant theta plus tan theta minus cosecant theta plus c. And if we remember that x is secant theta, we can find all the things we need by remembering that secant is hypotenuse over adjacent. So in that sense, you can think of x as the hypotenuse and 1 is the adjacent. And by the Pythagorean theorem, This must be square root of x squared minus 1. Just made a triangle based on our substitution we used. So now we just plug. We already said that x was secant theta, so you have ln x plus tangent is opposite over adjacent plus, right, x squared minus 1. Square root of x squared minus 1 over 1 is just square root of x squared minus 1. Minus cosecant theta. Cosecant is going to be x, the hypotenuse, over opposite, square root of x squared minus 1. Minus x over square root of x squared minus 1. Plus c. Right, this helps.